So now we're going to talk about learning target 12, which says I can find the solution to a system of linear inequalities by, let's say, by graphing and determine if a point is or is not part of the solution. Now, when we had systems of equations, we talked about that there were several ways to find the solutions. We could solve by graphing, substitution, or elimination. But when you're talking about a system of linear inequalities, the only way you can solve it is by graphing. Graphing is the only way to represent all of the possible solutions. If you solve this with substitution or elimination, you will only get the intersection point. You won't get the entire solution. And we'll see kind of what I mean in a second here after we graph it. So if we're going to graph this, y is greater than 2x minus 5. So remember, we have start at negative 5, and the slope is 2 over 1, 2 over 1, of 2 over 1, 2 over 1, over 1, 2 over 1, and so on. Now, if it is a less than or greater than without the line underneath, like how these ones have a line underneath, we're going to do a dotted line. So I'm going to make a dotted line right there. And if it's greater than, which is what this is, y is greater than, that means I'm going to shade everything greater than my line or outside of my roof. If this is the roof of my house, I'm going to shade everything greater than that. So everything out here. Now this equation, I'm going to find the x-intercept by putting 0 in for y. So if I put 0 in for y, then that goes away, the 4y goes away, and I just have 3x is less than or equal to 12. So then I divide by 3, divide by 3, so x is less than or equal to 4. So my x-intercept is out here at 4. For my y-intercept, I have, well, let's do this a different way actually. I'm thinking that's going to be better a different way. Let's change this into slope-intercept form. So we have minus 3x, which turns it into 4y is less than or equal to negative 3x plus 12. Divide by 4. So y is less than or equal to negative 3 over 4x plus 3. So that divided by 4 is negative 3 over 4. 12 divided by 4 is 3. So I'm going to start at 3. Then I'm going to go down 3 over 4. This one is less than or equal to, so it's going to be a solid line. And it says less than, so it's everything less than the line, which means it's going to be under my roof, which is down here. Now, if we were going to solve this by substitution or elimination, we would have only gotten that point right there, where those two lines are intersecting. But the solution to a system of inequalities is where the graphs are intersecting, but the graphs are not just represented by these lines. In an inequality, the graph is represented by the line and all of the shading. So we're not just looking for where the lines cross, we're looking for where the shading crosses also. So the solution is actually this area over here. All of this is where the shading crosses. This is all, so we're going to shade that extra dark here. And this represents all the points that would be a solution to both of these inequalities. So our solution set is all of those points, not just the point on the intersection of the line. Now let's look at this one. We have y is greater than x minus 2. So I'm going to start at negative 2. Then my slope is 1 over 1. So I'm going to make a dotted line right there. Now for this one, I'm going to start at a positive 3. And my slope is negative 1 over 3. So I'm going to subtract 1, go over 3, subtract 1, go over 3. And this is also going to be a dotted line. Now let's figure out my shading. Of this first equation right here, it's y is greater than. So it's everything greater than my line or outside the roof, the great outdoors. For my second equation, it's y is less than. So it's everything less than my line. So it's all of this. So the part where they overlap is right in this area. So that is my solution. And now we can think, is the point 32 a solution to each system? So let's see. 1, 2, 3, 1, 2. Right there. Because this point is not in this solution set, it is not a solution to the system. So first system, nope, not a solution. It's not in this area. Second system, let's look over here. 1, 2, 3, 1, 2. It is not a solution. Even though it appears to be in that set right there, it's actually right on the line. Now, because this is a dotted line, the dotted line means that the line does not include the solutions. It's just everything less than the line. It is not including the line. So is 3, 2 a point in the solution set for this one? Nope. Because it is on the dotted line. If it were a little bit lower and actually in the area, it would be a solution. Or if it was on the line but the line was solid, it would be a solution. But if it's on the dotted line does not count as part of the solution. That's why it's dotted, because it's not actually there. It's like a fake line. Okay? So that's learning target 12. Have a really good day.